So is it visible? Is it visible?
Yes, ma'am.
Okay. So I'll be discussing about inheritance. Okay. So we in normal the introductory classes sir has discussed that that there is a property called inheritance by which if there is an existing class, we can create some other class from that class. Okay. Or if you simply take the biological inheritance, we see that there are some of the properties that grandparent or parent is having, and then the same properties are coming to the children's. Okay. So if we try to model these things in any programming language or any programming language environment, so those things are known as inheritance. And also we will try to study how we will be implementing inheritance in C++. Okay, so for that, let us take real world example first, and then gradually I'll try to make you understand that how these real world examples are need to be viewed, how they need to be designed, and then after once we means designed according to object oriented design structure, and once we able to design an real world situation, then we will be implementing the same situation in our C++ language. Okay, so let us start with a very simple example. So the first topic is specialization and generalization hierarchy of classes in real world. Okay, so I'll be taking one example of a room. Okay, so let us try to find out this particular class room. Okay, and its features, and then I'll try to model all the rooms that are there in a college building and what are their uses, and I try to model them in an object oriented data structure. Okay, so let us take a simple class called room, more general class we can say. So in this room, these are the data. Let us consider these are the data, that is room number, area, the lights, the rooms are having lights, fans, internet connection, etc. Okay. Now there may be different types of rooms. Okay, in a building, there may be faculty room, there may be lab room, or there may be lecture halls. Depending on different properties and different behaviors, we can we can have different categories of rooms. Why? How? That is, say for if we take the example of a faculty room is having all the properties of a normal generalized room, like it will be having a room number, some area, it's also have lights, fans, internet, etc. Along with these properties, along with these characteristics, it is having two more characteristics, like the faculty room must have an office desk and it may have a workstation. Okay, and what we can do in a faculty room, the faculty who stays in that room, they can work, they can conduct some meeting. Okay, or sometimes the faculty may relax and play some songs, etc. Okay, so these are the data, these are the characteristics or data, and we know these are the behaviors or the methods or actions that we can conduct in a faculty room. Okay, so we all know that the classes, different class are having different behaviors, different data members, etc. So we are dividing, we are creating more generalized, more specialized classes from this generalized one. Okay, we can say that room is a generalized one. So lab room, faculty room, lecture hall, all of them are having all the properties of room, and along with that they are adding their own properties. Okay, so for lab room also, the labs are having desktops and ACs. Okay, and in the lab room we normally we can conduct different type of experiments. And there may be some lecture halls, they also have the properties of room along with them. The lecture halls may have galleries, they can have blackboards or whiteboards, and in the lecture hall we can take lectures. Okay, so we can say this, from this structure we can say this faculty room or lab room or lecture hall is a room which are having their own properties. Okay, So just you recall the example of fruits that I have given, that in fruits we can say banana, we can say apple, we can say mango, orange, all are fruits, but they differ in their data, different types of characteristics. Similarly, faculty room, lab room, lecture hall, all are rooms, okay, but they differ in their own properties. They are having these properties, this room number, light, fan, etc., internet, etc., and again they are having different other properties. Okay, so I have tried here to keep all the new properties of lab room, faculty room, lecture hall in blue color. So to means it makes easy to understand that what are the newly added features and what are the methods. Okay, now for example, say we can have further specialization for the lab room, lecture halls, and faculty rooms. Okay, so what are they? Let us see for the lecture hall. So if we consider that there is a smart classroom, so smart classroom means the smart classroom also have room number, area, lights, fans, gallery, blackboard, whiteboard, etc. Or maybe some of the properties are missing, but it can add some new properties like smart board, OHP, camera, speaker, mic, etc. Okay, so we can say the smart classroom is a lecture hall, where lecture hall is a room. Okay, so all the properties of room is also coming, it's also coming to lecture hall, and all the properties of lecture hall and rooms are inherited, we can say are inherited into smart classroom. Classroom is having all the properties that are in rooms and that are in lecture halls, along with their own properties that are written in blue. And when we look into the methods, you can see there are different methods. So this take lecture method is there for the lecture hall. This method is also there, take lecture. But what we are doing, we are taking this lecture. Some faculty is taking the lecture with speakers and mic. So previously this take lecture is conducted with blackboard, chalks, etc. Blackboard, whiteboard, chalks, or pens, etc. Okay, but now what we are doing, we are taking the lecture with speaker and mic along with other whiteboard, blackboard, etc. We are taking the lecture with mic, or sometimes we take interactive online class with recording. Okay, so this take lecture, this is a new one. Okay, and we can also do some video conferencing. So in a smart classroom, it is different than the lecture halls. Okay, so what happens here, if we have this method take lecture, and again we are having this method take lecture. Okay, it is some kind of doing method overloading or function overloading, because we are passing some new parameters to this take lecture. We know that whenever the function is having similar name but it differs in the signature, then the function overloading happens, isn't it? So if you have similar function name but different arguments, you are passing different arguments, so you can consider this take lecture is overloaded. This take lecture is overloaded. Now say if you want to keep the signature as well as the name same. Okay, so what happens there? If we keep the signature and the name, signature, that means whatever arguments we are passing, number of arguments, type of arguments are passing, that is same for two different classes. Do you know what does it call? Any idea? Are you getting my point? Hello?
Repeat the question.
I'm telling that if I have this take lecture method, this is a method function, data function, sorry, member function. Okay, so we know that in function overloading what happens, we are having similar name of the function. Okay, both the function name is same in this class lecture hall and in the smart classroom. Okay, but we are having different set of arguments in these two. So what does it, what we call this as function overloading.
Ambiguous.
Overloading. Now my question is, if I have the function name, same function name, say function 1, with some argument list in one class, say class A, and in class B, again we are having one function 1 with the same number of arguments. That's everything. The signature is same. Signature means name and argument list. Both are same for class A and class B. For class A and class B. Okay, only the body differs. Its body differs. Okay. So is it possible to have this? Or do you know what does it called?
Overriding.
Yes, function. That time it is known as function overriding. Okay. So when we study inheritance, we will be checking out the function overloading and function overriding thing, because there may possible that we will be having similar type of this one is inherited, this particular method is inherited, and this method, the same method is overloaded. We can find overloading, we can find overriding, etc., or we can have some new functions. Okay, so my point is, whenever we do some we create some special classes, we'll be having, we can do some overloading or do some overriding. Okay, now say if we take the lab room thing. Okay, so the lab rooms may be of different types. Okay, it may happen that some person is carrying some particular research in the lab room. Maybe there is the department is doing some project on robotics, and there is a dedicated lab room where the students can come, they can create some robots, they can do some experiment. Okay, and all the research work, all the experiments will be concerned with the robotics project. Okay, so that is a specialized one, specialized research room. Okay, it may be robotics, or maybe some other research room is there where we are checking out different image processing thing. Okay, image processing project. So it may happen that there are lab rooms, but they are having specialized use. Okay, so we can again divide the lab room, or we can again create two specialized class from this lab room class. It may be research lab room, or it may be sessional lab room. So what we do in sessional lab room, the sessional lab room, we can do different experiments, we can take labs. Okay, and students, when the students are means they're free, they can come to the sessional lab room, they can do their own experiment, or they can do some practice. Or it may happen that teacher can come and they can show some tutorials, they can show some method, means problems, solving some problems, they can take some tutorial in the sessional lab room. So what is my point, that even if you are creating research lab room or sessional lab room, they are having all the properties of their parent class. We can say their parent class, that is the lab room, or the grandparent class, that is the room, along with their own properties. Like the research room, they will be having some dedicated server for the particular research, or maybe there are cubicles where the research scholars can sit. Okay, or in these rooms, that is in the research lab room, they do some experiment. So this do experiment method is overloaded here. So before the do experiment method in the lab room, we do different types of experiment, and here we do only research experiment. Okay, but in the sessional lab room, we do only sessional experiments, and we can conduct research related meetings in the research lab room. The students can also relax, have a chat with the supervisor, or can play songs, etc. And similarly, in the sessional lab room, we can have lab practice or tutorial, etc. So how they differs? They differs by the methods, they differs by different characteristics, but they're having some common characteristics. Okay. Now say, for example, if there is a faculty who does a particular research in some area. Okay, so sometimes faculty they shifted to the research room where two or means their research scholars all are gathered there in the research room, and then the faculty can stay there, faculty can work in the that room, also can do their research. Okay, so with the properties of faculty room and research lab room, we can create a project research lab. Okay, so project research lab. In the project research lab, we can have some coffee machine, we can have some refrigerator along with all the properties of rooms, faculty rooms, research rooms, etc. So there the person can work, they can do some experiment based on the specific research, or they can have only project related meetings, okay, or they can relax. They can have coffee or drinks and soft drinks and they can relax. Okay, so these are the different properties. So here from the whole picture, you see, if I try to model all the rooms in our department, okay, so we can see there exists a substantial overlap in features and functions of different room types. There I have created 1, 2, 3, 4, several. I think 1, 2, 3, 4, 5, 6, 7, 8 different 7 different types of rooms. We have specialized rooms from the more generalized class, that is this classroom, that is the first room. Okay, so we have created this thing, these specialized classes or the specialized rooms from the more generalized class called room. Okay, so we see that there are substantial overlap between the features and functions. Okay, so here the smart classroom, if we take the example of smart classroom, it is more capable than a lecture hall. Okay, and can perform almost different types of functions. So it is more capable. So this type of specialization and generalization hierarchy can be found in different real world problems. Not only for rooms, there may be anything, any means you can model it anywhere. Okay, you can model it for any entity, any specialized class. So let us take one, see some more example, or rather, if I just remove all the properties and all these things, if we will be checking out, we'll be getting one object-oriented design. Okay, so we are getting a easier relationship between different classes. We can model them in a object. We can say that this is a hierarchy of object-oriented design of a real-world example called rooms. Okay, so now this in real world, we can have some specialized and generalized class, and if we want to model this thing, if we want to implement this thing via some code, okay, so this C++ models this is a relationship using inheritance features. Okay, so we will, that is our objective, to study that if there is a easy relationship between two classes, then how to model. Okay, and what are the different types of inheritance feature. So based on that, we need to model them. Okay, so we need to keep in mind whenever we will be creating different classes, we know that how to create class. We know that we'll be just writing down class, this type of definitions called class room. Then we'll be having its data members, and then in the public section we'll be having the member functions, and this is the definition. But when we define these more specialized room, or when we define these more specialized rooms, or this one, the project lab, which is taking these properties and these properties, so how to do that? So we need to change the class declaration, class definition. We need to change it. So how we'll be doing that? Okay, so that implementation part will take care in this chapter. Okay, so let us take 2, 3 more examples. Just I am briefly discussing them. So let's see this one, the scholar. Okay, so the scholar, if I take this one as a class, the scholar may be full-time scholar or they may be part-time scholar and full-time scholar. So what are the data? What are the feature of a part-time scholar? The part-time scholar is a scholar who is having registration number, some allotted supervisor. He or she will be having some course credit. Along with that, the part-time scholar need to pay some fees to the college. Or there may be some restriction that the part-time scholar need to maintain some contact hours with his supervisor. That is a necessary thing. Similarly, for the full-time scholar, the full-time scholar need to pay fees, and he is also having registration number, allotted supervisor, etc. But along with that, the full-time scholar is getting some stipend from the college, okay, from the institute. Or the full-time scholar they need to do some TA-ship. TA-ship means they need to conduct some labs, they need to check some copies or take some tutorials, take some classes, etc. Okay. So these are the responsibilities. Part-time, in the other hand, the part-time scholar, they don't have those kind of responsibilities. They are not getting stipend and they don't have this kind of responsibilities. Again, we can see there are different types of full-time scholar. Okay, say the project scholar. So if department is conducting some kind of project and they will be taking some scholar from outside who will be working on that project only. So project scholar will be paid from a sponsor of the project. That means, say some project is done in the department with collaboration to some other external institute or external organization. So that is a funding organization, or we can say that is a sponsor, and that funding organization is giving the stipend, and the student and the project scholar is getting his stipend from there, and it is having some project name. And the institute scholars, they also having stipend. Okay, but the institute scholars are provided with accommodation, and their stipend is having some kind of duration. Okay, for the project scholar, the duration of the stipend is up to which the project continues. But for the institute scholars, there are certain duration like 4 years or 5 years, they'll be getting the stipend. And there is one more scholar who is known as the QIP scholar. This QIP scholar is a specialized class. They're having all the properties like a full-time scholar, and they may be the employee of the institute. They may be the employee of the same institute, or maybe the employee, not same, QIP scholar are the employee of the external institute. Say, for example, there is a scholar from NIT Durgapur who is an employee of NIT Durgapur. Okay, and he or she gets a chance to do some research, some project work in IIT Kharagpur. Okay, so that is he or she is known as QIP scholar. So that time that particular employee who belongs to NIT Durgapur is drawing some amount of salary from the institute. Again, they will be getting some of the stipend from where he or she is doing the research. Okay, and they will be provided with accommodation. There are certain duration and some affiliation. Okay, so this QIP scholar, they are having all the properties of an employee who is having employee ID, designation, salary, etc. He is having a role in his college. Again, he is a full-time scholar who is getting stipend, TA-ship, etc. Okay, so my point is we can create specialized and specialized classes from the generalized one. Okay, similarly, the part-time scholar may be external part-time scholar, they may be internal part-time scholar. Again, we can divide the employee into this kind of hierarchy. We can see this type of ISA relationship. So employee, so this QIP scholar, we can say is an employee of some institute. He is a full-time scholar also. Similarly, we can say this external part-time scholar, he is an employee of some other institute and also a part-time scholar. Okay, so there are different things, there are different classes. We can create this, you can see in normal examples, we can create this generalization and specialization hierarchy. You can see here there may be two types of employees, permanent and contractual. Again, the permanent employees can be divided into staffs, they may be administrator, they may be faculty. Again, if we consider dean and HODs, all dean and HODs, they are permanent employee, but they are administrator as well as they are faculty, but they are having different responsibilities. Like dean will be taking care of different sections, like dean, we have dean student welfare, we have dean faculty welfare, we have research and consultancy dean. Okay, who is looking after different sections, where in the other hand, HOD is looking after different departments. Okay, so this specialization and generalization hierarchy, this is a real world example. Again, if we take an example of some data structure, like in trees, you can find this. Similarly, for queues, we can have DQ, priority queue. Okay, or one more example like that we are familiar with, that is the phone. Okay, so previously there is a landline phone, but it can be divided into speaker phone and cordless phone. Okay, and if you just consider the properties of speaker phone and cordless phone, we can create a mobile phone. Okay, and the mobile phone again added with some more features of AI and others, it can be a smartphone. Now the smartphone can be Android phone, it can be iPhone, or can be a tablet phone, etc. Okay, so you can see, we can say that smartphone is a mobile phone is both speaker phone and cordless phone. So you can see different types of hierarchy. Okay, so we need to implement these hierarchies through the inheritance. Okay, so let us see how we'll be doing that. So that I have discussed all these things, that the mechanism by which object of one class acquires the properties of object of some other class, this is known as inheritance. Okay, so here all of them, they are having they're acquiring the properties of some existing class. So this existing class is known as base class. Okay, so from now onwards, whenever we tell this is the base class, we'll be telling about the existing class, and the new class that is derived from the existing class is known as the derived class. Okay, so base class and derived class. And derived class, they acquire some or all properties from the base class. Now, the next point is that how the derived class inherits them, or how we will be writing down the codes so that we say that how much properties are derived in the derived class. Okay, so based on different types. Okay, there are means based on different different type of hierarchy, we can have 6 different types of inheritance. They are named as single, multiple, hierarchical, multi-level, hybrid, and multipath. Okay, so I have included a very good picture, and along with this, we are discussing different types of inheritance. So the single inheritance is a very simple one. There is only one base class, and this is the base class, and this is the derived class. Okay, and which one is derived from where? We put this arrow. Okay, so this arrow is essential. Whenever you are asked in exam, maybe in exam it is asked that how many type of inheritance you find. Okay, and give some example. That time if you draw these pictures, don't forget to write down the arrow. This arrowhead, this direction of arrowhead is very, very essential. Okay, so this is a single inheritance in which only one base class and one derived class. And for multi-level inheritance, if there is a base class which is derived from some other base class. Okay, so B is a base class which is derived from A, and C is a derived class that is derived from B. So here you can see the level-like structure. Okay, so B is acting as a base class for C, but B is basically derived from A, which is acting as a base class for D. Okay, so we can create this type of inheritance. We can see this type of things like room, lab room, and research lab room. Okay, so this is known as multi-level inheritance. Okay, next is if say there is a class which is created by deriving properties from 2 or 3 classes. Okay, so that is known as multiple inheritance. That means C is created by acquiring the properties of A and by acquiring the properties of B. Okay. Okay, just a second. Okay. Just a minute. I'm getting an important call. Just a minute. Okay, so we are discussing about multiple inheritance. Okay, now if we do just the reverse, that means in multiple inheritance we are having 2 base classes and 1 derived class. And if we do just the reverse, okay, we'll be having only 1 base class, and from which we are deriving different derived classes. That is known as hierarchical inheritance. Okay, so this is called hierarchical inheritance. And next is the hybrid inheritance. Hybrid means it will have different types of mixture of different types of inheritance. So in this example, we find this is a multi-level inheritance, and this portion is a what? Which type of inheritance this portion? Yes?
Multiple inheritance.
Multiple inheritance, exactly. This is multiple, and this is this A, B, D is multi-level inheritance. Okay. So this is called hybrid inheritance. And the last one, you see this one, there is a diamond-like structure. It is a diamond-like structure. So here A is a base class. The properties of A is going to B and going to D. Again, all the properties of B is going to C, and all the properties of D is going to C. Okay, C is created from B and D. So you can see here multiple inheritance. This one is hierarchical inheritance, and this part are multi-level inheritance. Okay, so actually what happens here, just a second. Okay, so what happens here, all the properties of A is coming to C via two paths. One is via B, another is via D. Now say for example, the properties are copied from A to B, then B to C. A property of A is copied from D to C. So there will be two copies. Okay. So there will be ambiguity. C don't know which copy to use, which copy of A need to be used. Okay. So there will be ambiguity. So that ambiguity need to be removed via the programming, and via some methods are there. Okay. So this is called multi-path inheritance, by which the properties are acquired by different paths. Okay. So is it clear? All the data and types of inheritance. So I'll take 5 more minutes. Okay, so I have created this one. I have completed this particular parts. Now we will be talking about different mode of inheritance. That means we said that the base class properties are, this is a base class. All the properties or all or some of the properties will be coming to the derived class. Okay, we told that. But the question is how much? All or some of the properties. The question is how much. Okay, how much properties will acquire. So this can be determined by how we are inheriting. So we can have 3 different inheritance mode. Okay, one mode is public mode of inheritance. One mode is called protected mode of inheritance, and private mode of inheritance. So till now we know there are 2 access specifiers, public and private. 2 means mostly use access specifiers. We know that they are public and private. So we know that by using private access specifier, we normally protect our data, and by public access specifier, we communicate among the objects so that any problem can be solved. These are the basic meaning. But why these protected access specifiers are required? Okay, so we'll be discussing this thing. Protected access specifier, in a brief, this is something like a little bit restriction on public and little bit relaxation on the private. So in the private access specifiers, everything is restricted in the private access specifier, but in the protected access specifier, it is almost like private, but a little bit flexibility is there. Okay, not all the things are restricted in protected. Okay, but you, in comparison to public access specifiers, everything is open in public, but protected is a little bit of protected, little bit of restricted in with respect to public. Okay, so how those things are implemented, we need to see. Now we will be considering public mode of inheritance. Okay, that how we'll see the simplest form first, and then gradually we'll be adding complexity. Okay, so you consider the figure that is drawn here in the right side. Okay, so here you can see the base class. I have named the base class as B, and for simplicity I have named the derived class as D. Okay, so this is the generalized class. They are having a easy relationship. Okay, now this one, this is the implementation. Okay, so here whenever you do whenever you try to create inheritance in your C++ program, there we need to design the 2 classes. the base class or the super class, and we need to write down the generalized class, specialized class, that is the derived class. Okay, so class definition for the base class is same, okay, that we have done before. Okay, so here I have not written the body, I have just shown you the syntax. Okay, but class B will be having a body like we have till now, it will be having a body. Now class D is something new. You see the declaration of class D. It's a little bit different than the normal classes. Here what we need to do, if we create some derived class from some existing class, we need to write down the existing class name. Okay, so we have written D is created from B, and this visibility mode or access specifier, it determines how much property we will acquire. Okay, there are certain rules related to it. If you're not writing anything here I have written public. Okay, if you're not writing anything here, it by default it takes private. Okay, so we'll discuss about private. So default visibility mode of inheritance is private. Okay, and when we are writing public, there are certain rules related to this public specifier. Okay, so this is the syntax. Okay, first we'll be writing the class name, then derived class name, then this colon, then visibility mode and base class name. Okay, and normally we'll be writing down its body. Okay, so whenever we create this type of thing, say B is having some property called, say B is having a data member called B1. Okay, and B1 and B2, say B is having two data members and D is having one data member called D1. So whenever you create this class D will be having B1, B2 from this B. It will be having all this and it will be having its own property called D1. Okay, so let us see how the memory is mapped. What is the memory implementation? So here I have taken the example of the same the classroom and the smart classroom. Classroom is a base class having these data members and method, and the derived class smart classroom, these are having these data members and all these methods. So here the method is overwritten, this is overloaded, and this is newly added. Okay, so what happens when we try to create inheritance in C++? So there are derived class that inherits all the properties of base, all or some of the properties of base class. Then the derived class may add its own data member. Regarding the data member, this is a point. For member functions, it may override or it may overload or it may add new member functions. There is a very important thing that is called member access specification. Okay, so this member access specification means whether we are deriving them as public or we are deriving them as protected or we are deriving them as private. Okay, how we are doing this? So if the derived class cannot access the private members of base class. Okay, so there is one rule, it is written, the derived class cannot access invisible or private data members of base class. Okay, so if you have the derived class, if you have the private class, private data members in the base class, say this is the base, there are some private data members, there are some public data members, say D1 and B1 and B2. Okay, so this B1 and B2 is inherited in D, but D cannot access B1. Okay, so I have just shown this thing through some pictures. Okay, I'll discuss this thing a little bit, and there are certain rules related to construction and destruction. Okay, into the base class and derived class. So base class can have constructor, base class can have destructor. So if you are doing inheritance, if you are implementing inheritance and if you have some derived class, okay, derived class also have some constructor and destructor. And in case of inheritance, the derived class is having all the responsibilities to construct the constructor for the base class. Okay, so the constructor of the base class will be depending on the constructor of the derived class. Okay, so those things also we'll be discussing. So we'll be discussing one by one. So let us take the private inheritance thing, public inheritance thing. Okay, here are certain rules I have written. So if this is the base class, okay, so if the data member is private, then they are not inherited. Actually, they are inherited but not accessed. Okay. And if the method is public, then if the derivation technique is public, it remains public. If the derivation technique is private, it becomes private in the derived class. Okay. So these rules we'll revisit again and again. Let us show you the layout of a derived class object. Okay. So first you consider the this picture. So this is a class. This is layout of a base object B. Okay. So what we have done, there are two classes. This is class B, that is the base class, which is having one private data member B1 and one public data member B2. Okay. And whenever we create object for B, so this B is created. So this is the memory layout B1 and B2. So this is private and this is public. Okay. Now there is a derived class. This is the definition of the derived class D. Okay, we have derived it as publicly. So if the derivation is public, if the derivation method is public, all the public members remains public and the private members are inherited but not accessed. Okay, they remain private. Okay, so you see this is the layout of the derived object D. So in derived object D, this part is derived from base class and this is its own. Okay, so we have written this class is derived from base and in the public section D1 is its member. Okay, so whenever we create D is an derived object. So this is the layout. Okay, now if I do these operations, here, this second, yeah, if I do this operation B1 dot B dot B1, okay, so what happened if we want to do this one B dot B1, that means B1 we want to access. B1 is a private data member, so it is giving some error because we know that main is a global function and from global function we cannot access the private data members directly. This we know, so this is giving some error. But if we want to access B2, B dot B2 works fine. Okay, now if I write down D dot B1, so I see that here D dot B1. So I see that in D, B1 is there, B2 is there, D1 is there. But if I write down, D dot B1, so it cannot be accessed because it is a private data member. It remains private. Okay, so it gives an error. It can inherit, but it cannot access. Otherwise, this B2, D dot B2 and D dot D1 all can be done. All can be accessed. Okay. So this is the rule. So you understand the rule? If we do it publicly, if we derive them publicly, so how much is inherited? I told that how much is inherited, that depends on this mode of access specifier. So similarly to the public access specifiers, there are certain rules to private as well as protected. Okay, so this thing you understand?
Yes, ma'am. Yes, ma'am.
Okay, so one more thing. This is the last slide for today's class. Okay, so if there is some kind of name clash, say for example, class B is a base class having a private data member B1 and public data member B2. Okay, again, D is a derived class which is having a private data member B2. Okay, so D is deriving this B2. That means B is having B1 and B2. Now, whenever we create D, D will have this B1 and B2. B1, but it is restricted, not accessed, and B2. And along with that, it is adding its own B2. It can have another data member called B2. Now the ambiguity is if I want to access B.B2, which B2 to consider? That is one that is derived from B or the original one, the local one. Okay, so if you write down this kind of thing, say B.B2. So B.B2 will be accessing this one. But if you write down if I create an object called D, and if you want to access this one, which one it will be accessing? This one or this one? That we don't know. There may be an ambiguity. So this name clash can be overcome. We can resolve this ambiguity by using scope resolution operator. Okay. So this is one example I have given here. Just here this B scope resolution B2. So we have written here and this B2. So if I call this one, if I now do this one from the global function, or we call this function, it knows which one is to check. Okay, so I'll be showing some of the examples in the next class if possible. Okay, so this is how we can resolve the name class wherever there will be this type of thing. We'll be using scope resolution operator. Here also we can use scope resolution operator. Okay, so I'll be showing you, and I'll be checking out these things later also. Okay, so this portion up to this much is completed. We'll next discuss about protected access specifier in our next class. Maybe tomorrow I'll be taking one more class. Okay, and I'll discuss protected access specifier. So till now, if you have any query, you can ask me.